Have you ever wondered how Amazon recommends the perfect product? How Netflix always know our next favorite show? So behind all these apps, there is a massive amount of data being processed every second. And to handle this huge amount of data, companies rely on powerful platform like Databricks. So Databricks was actually founded by the creators of Apache Sparks and trusted by more than 10,000 companies worldwide, from fast growing startup to Fortune 500. Whether it's an e-commerce, finance, healthcare, or social media, most companies are building their modern data infrastructure on Databricks because it unifies the data engineering, data science, and machine learning in one platform. Hello and welcome to TechnoAarambh. In this video, we'll cover everything you need to know about Databricks. So in that, we'll first understand what it is, why it is so powerful, and why so many companies are using it to process massive amount of data. And by the end of this video, you will have a clear picture of how Databricks powers in the data-driven world around us. So what exactly Databricks is? At its core, Databricks is a cloud-based platform that helps companies to store, process, and analyze huge amount of data all in one place. It builds on top of Apache Sparks, but it adds a lot of extra features that makes working with data faster, easier, and more collaborative. So imagine you have a library with millions of books. Some books are in different language, some are old and some are new. And if they are all scattered around, if you want to find a single book or get insight of thousands of them, it would take forever. Databricks act like a super smart librarian. It organizes all these books, make sure they are updated and clean, even helps you run analysis like which author is most popular in this year or which is trending. And that's why company like Amazon, Netflix, Uber, and thousands of more uses Databricks to handle their massive amount of data and turn it into insights, recommendations, and machine learning models. And in simply, Databricks is a unified platform for data engineer, data science, machine learning, and analytics all working together on the same data. So let's rewind back to the early 2000s. This was the time when big data was just starting to explode. The social media platform like Meta or Twitter were gathering endless streamless of posts, likes, and comments. E-commerce sites like Amazon were logging millions of click and transactions every day. IoT devices and sensors were producing continuous logs of activity. The world realized that we have now more data than ever before. But here is the challenge: how do we actually process all of this? At the time of the most popular tool was Hadoop with its MapReduce framework. And to be fair, Hadoop was a game changer when it arrived. It allowed companies to process massive datasets by distributing work across many machines. But Hadoop had some serious drawbacks. First, it was batch oriented, meaning you have had to wait until all the data was collected before you could process it. That was fine for reports that run overnight, but trouble if you wanted real-time results like fraud detection or live recommendations. The second drawback was the programming model was very complex. Developers had to write long, low-level Java code just perform simple transformations. And the third drawback that was Hadoop was insufficient for interactive jobs like machine learning. Every time you run a steps, Hadoop would write data back to disk, slowing things down massively. So the picture is data scientists trying to build a recommendations model in the mid of 2000s. Every experiment could take hours, sometimes even days, just to run one version of the job. By the time of the results come back, the data might already be outdated. And that's very frustration. And that's frustration, the need for faster, simpler, and more interactive data processing is exactly what. So as the world struggled with the slow and complex data system like Hadoop, group of researchers at UC started asking simple questions. Can we make a data processing faster and easier? And the question gave the birth to Apache Spark. Spark completely changed the game. Instead of writing a data to disk after every step like Hadoop, Spark introduced in memory processing, meaning it could keep data in memory and process it almost instantly. This made up to 100 times faster than Hadoop for certain workloads. But speed wasn't Spark's only superpower, it also brought simplicity. You no longer needed to write hundreds of lines of Java code to perform basic data operations. With Spark, you could write few lines of Python or Scala and get the same job done in seconds. And the best part, Spark was unified. It wasn't just for batch processing, it could handle streaming data, SQL querying, machine learning, and even graph processing, all from a single platform. So imagine a data engineer could clean and transform petabytes of raw data. A data scientist could train machine learning models on the same platform, and the analyst could query the data with simple SQL queries, all using Spark. This was revolutionary. Companies like Netflix, Uber, and Amazon quickly adopted Spark to process real-time data, build recommendation system, and power their analytics dashboards. So in short, Spark made working with big data fast, flexible, and developers friendly. But even with all these advantages, there was still a gap. Managing Spark cluster, scaling them, handling data reliability, and deploying models into the production, that still required a lot of manual work. And that's when the creator of Apache Spark decided to take to the next level. They build a unified managed platform that makes all of this easier. That's what we now known as Databricks. So Apache Spark gave us speed, flexibility, and unified way to process data. But in real world companies, managing Spark wasn't always simple. Think about it, you still had to set up a cluster, manage configurations, handle version mismatches, and make sure your data was stored safely and consistently. And different teams like data engineer, analysts, scientists were still working in different tools. A data engineer might use Spark for ETL, a data analyst might use Power BI or Tableau for reporting, and scientists might experiment in Jupyter notebooks. Bringing all of that together into a smooth workflow was still a huge challenge. And that's when the creator of Apache Spark stepped in again, this time with a million. Let's build a one unified platform where everyone from engineers to scientists can work together on the same data in real time. And that version became Databricks took everything powerful about Spark and made it simple, managed, and collaborative. No need to manually manage clusters, it's automatically in the cloud. No need to switch tools, no more inconsistent data, no more messy models development. With MLflow, you can track versions and deploy machine learning model with just few clicks. In simple terms, Databricks become the home for all things data. From collecting raw information, cleaning and transforming it, training machine learning models, and finally deploying them to the production, all in one place. And that's why today over 10,000 plus companies from small startups to massive enterprises uses Databricks to power their data infrastructure. Whether it's Netflix recommending your next movies. So in short, Databricks builds on the foundation of Apache Spark, but it transforms it into a fully managed, collaborative, and end-to-end data platform, making big data, machine learning, and AI accessible to everyone. So now that we know why Databricks come into the picture, let's understand how it actually works behind the scenes. So think of Databricks as a smart workplace. in the cloud, where data engineers, data scientists, and analysts can all come together and work with data, build models, and run analytics without worrying about managing the infrastructure. But what happening under depth? Let's break it down step by step. So at the high level, Databricks is divided into two main layers. That is number one, control plane and compute plane. And in the older setup, there was also something called classic plane. Let's understand these one by one. So now let's understand what is control plane. So imagine you are using a Databricks through your browser, creating notebooks, scheduling jobs, or managing cluster. All that configuration and management logic, like your notebook, metadata, user access, and workplace settings, is handled by the control plane. So you can think of the control plane as a brain of Databricks. It knows what need to be done, but doesn't actually process data itself. In the cloud terms, the control plane is managed by Databricks. It lives in the Databricks managed cloud environment. Managing Databricks take care of security, uptime, and management here. And then number two, that is compute plane. So now the actual heavy lifting, the data crunching, happens in the compute plane. When you run a job or execute a notebook cell, the control plane tells the compute plane, hey, spin up a cluster and start processing the data. The compute plane is created in your cloud account, whether it's Azure, AWS, or GCP. And that's where your virtual machines or clusters live. So all your data stays securely within your environment. Databricks just orchestrate it. You can think of compute plane as the muscle that performs all the transformation, analysis, and machine learning model training. And in the older setup, there is also third layer, that is a classic plane. So before the modern split, Databricks used a single architecture called classic plane. In that setup, both control and compute components used to be in the same environment, simpler but less flexible and less secure. So the control plane is where Databricks manages everything. The compute plane is where your actual data processing happens in your cloud. And if you're using the older version, if you're talking about the classic plane, older all-in-one setup that has now evolved. This separation gives Databricks its magic, a managed, secure, and scalable way to work with massive amount of data and AI without managing infrastructure yourself. So that's all for the today's video. We covered everything from what Databricks is, why it come into the picture, and how it evolved from Apache Spark, and how its architecture work behind the scenes with the control plane, compute plane, and classic plane. So if you found this video very helpful, then don't forget to like, share, and subscribe to support the channel. And as I always say, keep learning, happy coding, and I'll see you in the next video. Until then, have a great day.